face to face, and also need to take care also the students who are in front of the laptop. Will you be able to see the whiteboard behind me? So we can try, no problem, we can try. But the condition in the tutorial classroom is not that uh, conducive. Tak ada plug lah, plug tak ada electric lah, lepas tu tak ada wifi lah, so on. This is what the other lecturers who have already tried and then they say. Ataupun awak dah jumpa tak hybrid classes with other lecturers? Sudah cuba ke belum?
MS9 belum lagi.
Subjek lain pun belum?
Belum.
Itulah yang jadi masalah sikit. Madam pun tengah fikir nak macam mana. Okay.
And
never mind.
madam, how about our class at 2 p.m.?
Okay, yang itu
They
tak...
stated
Because
stated in the jadual supposed to be experiment, isn't it?
Yes. Experiment. So that one no problem because that one is individual class. Practical is slightly easier, but the problem is the tutorial and the lectures, especially for MS32. I feel sorry a little bit for MS32 lah. Okay. But no problem, madam. Repeat sekali lagi. Okay, and then we will continue. You just take it whatever you can. Madam just try our best. Madam pun tak tahu macam mana nak buat dah. Okay. Please bear with me.
Madam.
Okay. Right. So in the morning just now, those who are already in the lesson, you can revise back again. For those who haven't joined the meet, okay, this is what we have touch and go for chapter 7. Okay, so in chapter 7, the very beginning, we want to understand acid and bases definition. Okay, so madam have already wrote over here acid and bases, actually they have 3 definition. Okay, they have 3 definition, which is according to 3 different scientists' name. We have Arrhenius, Bronsted, Rowley, and Lewis. The Lewis in this part, it means Lewis acid, Lewis base. It's different from the Lewis structure that we learned before. Okay, so Arrhenius acid, it means any substance that has a hydrogen, and when it dissociate in water, that means it dissolve in water. Dissociate is the same meaning as dissolve. And then you'll get this H plus hydrogen ion and hydronium ion H3O plus. So the example equations over here, either you have water, you don't have water, H plus, H3O plus, they are actually the same thing. Okay, and then for Arrhenius base, is any substance that we have OH, or when it is dissolved in water, okay, it will form this OH ion or hydroxide ion. The name you can slightly jot down, hydrogen ion or proton, hydronium ion is H3O plus, hydroxide ion is OH minus. So Arrhenius definition is simple. Okay, so all these definitions can describe acid and base, but it's just in different contexts. So this is Arrhenius. And then we have also talked about Bronsted Rowley, the second scientist over here. Okay, so for Bronsted Rowley acid, so it's referred to any substance that can donate a proton. So proton in this case, it refers to a H plus hydrogen ion. So acid can donate H plus. So it makes sense, right? So at the same time, Bronsted Rowley acid, when it donates the proton, it will produce the conjugate base. So the arrows over here, madams just want to indicate they are actually a pair. So acid, after donate the H plus, it producing conjugate base. So what is a conjugate base? It's a substance that remains, okay, after an acid donates the H plus. So the example down at the below for MS32, those who haven't joined, madam will explain in your in the following tutorial lesson when you have only MS32 inside the Google Meet. Remind madam on this one. Okay, so conjugate base is after an acid donating the H plus. Whereas for Bronsted Rowley base, a base that can accept a proton. So Bronsted Rowley is just focusing on the proton H plus. acid donate proton, so base will accept proton. So the function, the property is opposite direction. Acid donate, and then base will accept proton. So when a base, a Bronsted-Rowley base, accepting a proton, it will produce its conjugate acid. So it's a pair, base conjugate acid. Okay, so conjugate acids refer to a substance that remains after a base accepting H plus. Okay, so until this part is just the definition. Okay, you will further understand it when you look into the example. Okay, so again, MS32 method will separate explain this one with you in our following class, yeah? Okay, so remember this, Bronsted-Rowley, focusing on the proton. So Arrhenius, you just HOH and then it dissociate and so on. But Bronsted-Rowley, it just depends on proton, whether it's donating the proton or accepting the proton. And then this conjugate acid base pair is only for Bronsted-Rowley, yeah? It's only for Bronsted-Rowley. If you got acid, it definitely will produce conjugate base. If you have a base, definitely you are getting the product conjugate acid. Okay, so in the equation, you will always see two pair. Until this part, is everyone all right?
Alright, madam.
Okay, yeah. Okay, and then the third definitions. Okay, the third definitions over here refer to a Lewis acid or Lewis base. So for Lewis, it will focusing on the pair of electrons. So if you look at the definitions of Lewis acid, Lewis base, we're focusing whether it is accepting the electron pair or it is donating an electron pair. So Lewis acid, it can accept a pair of electron. So just now we say Bronsted-Rowley donate proton, right? In this case, it is accepting a pair of electron. So all these three definitions, it can explain what is an acid. It can explain what is a base. And then you need to look through the example, especially for Lewis. There is so much example. Okay, so acid accept a pair of electron. It can be the cation, H plus, Fe2 plus, Al3 plus. Then the molecule with incomplete octet central atom, which is beryllium, boron, aluminium, if you still remember from your chapter 4. Okay, and then number 3, molecule that has polar multiple bond except for CC double bond. And then when you have the molecule with the central atom that can expand, that means it's the element from period 3 and beyond. Period 3, period 4, period 5, and so on. So all this, whenever you see the example, it belongs to a Lewis acid, which can accept a pair of electrons. Whereby a base, it can donate a pair of electrons. How to donate? As long as you have a pair of electrons. So the very easy example is anion. When you see a negative charge, that means it has extra electron to be donated. When you have lone pair, so you can donate a pair of electrons. Or maybe if you have a non-polar multiple bond, such as alkene, carbon-carbon double bond, or alkane, carbon-carbon triple bond. So it depends on the definition which one you want to refer to. Is it Arrhenius, Bronsted-Rowley, or Lewis? So again, MS32 madam will explain the example with you in the next class. So starting from this page, now the strength of acid and base is where we stopped just now. We stopped at Lewis just now for MS7, 8, and 9. So from this part beyond MS32, I think you can catch up with this one. Is quite different from the definition just now. Okay. So strength of acid and base, when we talk about strength, we have a strong, a weak. That's it, two of this one. Strong acid, strong base, weak acid, weak base. And you must remember, or you must memorize all the examples for the strong or weak acid, strong or weak base. Okay, so in this case, we start with acid first. So a strong acid, say, is an acid that can dissociate completely into ions in water. Dissociate completely, that means if you have 1 mole of an acid, a strong acid, it will completely dissociate 100%. So given over here, HA is a general formula for an acid. So either it's given in gas or aqueous state. So remember just now, the equation, you can either add water or you don't want to add water. So if you add water, so after it dissociates into in the water, it will produce H3O plus and also your conjugate base. Acid produce conjugate base. So boleh catat lah dekat sini. Okay, so A negative, this one is your conjugate base, as it is produced from the acid. So after acid donating in H plus, you are producing your conjugate base. And if you don't want to write water, that is fine as well. So HA straight away dissociate into H plus. Okay, H plus, H3O plus is the same thing. Again, A minus, A negative is the conjugate base. So Madam wants you to take notes over here. You can either highlight or you take notes on the arrow. Completely dissociate, that means it is an irreversible reaction. After it dissociate, no ways to return. Okay, that is for a strong acid or strong base. So the examples over here, memorize these 7 species. Other than this is all considered as weak. So remember these 7 species. We have hydrohalic acid, HCl, definitely the hydrochloric acid you usually use, HCl. HBr, HI, strong acid. Oxo acid, HNO3, H2SO4, HClO4. When you see there is a lot of oxygen. So HNO3, take note on this one. H2SO4 definitely. And then HClO4. So these 7 species, Madam say 7 wonders. So these 7 species is your strong acid. Must remember. Other than these 7, they are all considered as weak acid. Are you good?
Yes, madam.
Yes.
Okay. And then for weak acid, it's an acid that dissociates only very slightly into the ions in water. Okay, so you can either choose to dissolve in water or not. So again, the same thing. If you use water, you're producing H3O plus. If it doesn't, then you're producing H plus only. Okay, so both are accepted. But in this case, if you're having a weak acid, take notes on the arrow. Weak acid only dissociate very slightly. That means majority of the acid will still remains as HA. As will still remains as the acid. It won't separate into H plus, A minus, H3O plus, A minus. No. It will mainly remains as the acid. So take notes. Dissociate slightly. You need to use a reversible arrow or equilibrium arrow. Another words for slightly, you can also use partially. The acid that dissociate partially. That means not completely dissolved in water. So the examples over here, we still having hydrohalic acid, but in this case, HF. Why HF? Because fluorine is very, very electronegative. It won't release the hydrogen that easily. So you need to think about this one. The more easier are releasing the proton, the more acidic is the acid. Sebab dia senang nak lepaskan H+. Tadi kita cakap kan, dia an acid will donate H+. Kalau dia senang nak lepaskan, dia lagi acidic. So for HF, due to the strong electronegativity of your fluorine, so the hydrogen is less likely to be released. Therefore, we will consider HF as the weak acid. So kena pastikan HF, jangan nampak fluorine, oh dia sangat electronegative, dia mesti strong. Tak, dia adalah weak acid. You get me?
Yes, madam.
Okay. Then we have the following example, oxo acid over here. If you realize HClO and HNO2. And then this one, the phosphoric acid is considered as weak acid. Madam just want you to differentiate between two of this. You see, HClO4 strong, HClO weak, HNO3 strong, HNO2 weak. So make sure you know how to differentiate between two of these examples because they are they look very similar, but you have to understand the differences and then categorize both of them nicely. Who is strong, who is weak? You need to remember well. Phosphoric acid is definitely a weak acid. Okay. And then the next example, acid in which hydrogen does not bonded to FON. Now, if you still remember, in the previous chapter, we talked about FON. You got hydrogen bonds, right? But when your hydrogen is not directly attached to FON or any of the halogen element, it is considered as weak acid. So examples over here, you got the HCN. Still, you are going to release H plus. So if let's say examples over here, I'm going to show you example. How am I going to prove this is an acid? Hold on a second. Contoh So if say HCN, this is an aqueous acid. If I want to dissociate into an acid, dissociate into water, so HCN, it will releasing H plus aqueous and CN minus aqueous. Kalau nak water boleh lah, awak akan hasilkan H3O plus. So if you see in your equation, you still can see this H plus. That means this will be an acid. So very, very simple. Boleh tak dia keluarkan H plus? Kalau boleh, okay, dia adalah acid. But it is considered as a weak acid. And the last examples over here, we have the organic acid. Organic acid in terms of carboxylic acid. So any of the carboxylic acid, COOH represent carboxylic acid, yeah, is considered a weak acid. Contoh, yeah, CH3COOH, your acetic acid or ethanoic acid. You can jot down over here. Acetic acid is the name for CH3COOH. So is everyone good for the strength of acid and base in this case?
Good.
Yes,
Good, yeah.
teacher.
Okay, then we'll look through the base. Similar things. Strong base dissociate completely. Therefore, we are using a single directions arrow. Okay, an irreversible arrow. Okay, because it's completely no ways to return. So BOH is the general formula for base. So B doesn't stand for boron, now B stands for the base. But if you want the example, the very simple example, we have NaOH, aqueous, dissociate to become Na positive, and OH minus. Okay, so strong base, straight away dissociate. No need water also can. But if you got water, then no ways you can slot in the water. So for a strong base, terus tulis dia punya dissociation equation saja. Okay, so water-soluble compounds containing O2 negative or OH minus are considered as the strong base. So the very easy example, if you remember about this, group 1, group 2, if it combine with oxide or OH, okay, OH minus, it is considered as strong base. So M2O or AO2. So for example, if I have lithium oxide, lithium hydroxide, sodium oxide, sodium hydroxide, potassium oxide, potassium hydroxide, they are all considered strong base. Okay, group 2 also can. Okay, so it will combine with the oxygens to produce calcium oxide, barium oxide, and so on. Calcium hydroxide, barium hydroxide, and so on. So any group 1, group 2. So that will be considered as your strong base. Whereby when you have a weak base, it will dissociate slightly into ions. So if you got a weak base, you must add in water in order for you to complete the whole equation. Okay, so must write in water in equilibriums to produce pH plus and OH minus. For example, the very common example used for weak base, contoh kita yang paling popular adalah NH3. So NH3 aqueous, when it dissociate into liquid, in equilibrium, you are going to produce NH4 positive aqueous. Kenapa Madam tahu NH4 positive? Tengok balik dekat definition. Refresh balik definition. A base will accept what? A base
Hydrogen
will
atom.
accept
Hydrogen
hydrogen ion.
ion
Bukan
ion.
accept hydrogen ion. Or it will donate a pair of electron. So kalau nak donate elektron, donate kepada siapa? Donate kepada proton. So sama maksud dengan awak accept proton. Okay, so NH3 after accepting a proton, it become NH4 plus. So dalam dekat sini boleh juga kita tulis ini adalah kita punya base. So water automatic akan jadi acid. Lepas tu NH3 after accepting proton, it becoming your conjugate acid. Ni cerita. So Arrhenius, Bronsted Rowley dengan Lewis sebenarnya dia campur-campur. Semua dia boleh pakai. Tapi kita kena tengok dia punya definition, apa yang kita nak buat. Okay, so base, after accepting, proton producing conjugate base. And don't forget about your OH minus. So water behaving as the acid, we will release proton. After releasing proton, you're left with OH minus, which is your conjugate base. Okay. Molecule with nitrogen center. This is the example weak base, very simple. As long as you see nitrogen. Okay, as long as you see nitrogen, it is always weak base. So molecule with nitrogen center atom that has a lone pair electron. For example, ammonia, ammonium, and then you have amine. So if you can see over here, the nitrogen can accept proton or it can donate the lone pair. NH4 positive, ammonium, you have the lone pair on oxygen. And you have the nitrogen atom as well. Okay, and then we have the amines, nitrogen atoms having the lone pair. Ammonium, Madam will explain further with you in another examples, but you just take note over here. Ammonia, ammonium, amine. Everything having nitrogen. Okay, but nitrogen must containing lone pair. Then only it can behave as a base. This one, Madam will explain in a further example. Okay, because we're using the lone pair on oxygen, not nitrogen. Okay, so is there any questions for the strength of acid and base? So far, so good?
Yes, madam.
Good.
Good. Okay. The next things we want to emphasize before we go into calculation is this one. Autoionizations of water. Water kan biasa benda biasa yang kita jumpa, air minum ke, air mandi ke, air masak ke, whatever. But how do you explain water in terms of its concentration? What is its pH value? Okay, so water dissociate very slightly into its ion in equilibrium, or we say self-ionization. Self-ionizations, auto-ionization, it means the same thing. Okay, so H2O, react with H2O, it will dissociate into H3O plus and OH minus. This equation is known as the autoionizations of water. Okay, so in pure water, we know the concentrations are equal. Okay, because you have this pH value equals to 7. If you still remember the pH range, we start from 0 until 14. So the neutral over here, pH 7, give you the pure water, neutral. But how are we going to know that the pH value equals to 7? From where we know pH equals to 7? Here is where you want to know. Okay, so concentrations in pure water for both H plus, H3O plus, or OH minus is equal. It, it is the same as 1.0 times 10 to the power of negative 7 because you're having a constant value Kw. This Kw is known as the ion product constant for water, and it has a value. So this Kw has a value 1.0 times 10 to the power of negative 14. And it is fixed. Dia adalah satu constant, value dia adalah fixed. Boleh catatkan ya. Meda highlightkan untuk awak. So for this value is fixed. That's why you can identify the concentration for OH minus and H plus. Okay. Hold on. Okay, so in order to find the concentration, H plus, OH minus, actually we can represent this one as 2x. So let's say we have a concentration H2O plus, concentration OH minus equal. So you know that the x value equals to the value over here, 1.0 times 10 to the power of negative 7, which is given already here. But then the value 1.0 times 10 to the power of negative 7 is actually come from your KW. Sebab ini bukan fix. Value untuk ini bukan fix. Tapi value KW adalah fix. Do you get what I mean?
Faham.
Faham? Macam tak? Tak apa, Madam cuba Kalau sekarang Madam bagi concentration H plus sama dengan 1.51 darab 10. Madam randomly give a number. Okay, I give you this concentration. How am I going to get the concentration for OH minus? Sebab Madam cakap untuk yang Madam bulatkan dekat sini dia bukan sentiasa fix. Tapi untuk pure water, yes lah. But we can always identify concentrations of H plus, OH minus from your KW. So how was it? Kita guna cara yang tadi lah. KW sama dengan H3O plus OH minus. Equation ini adalah sebelum ni yang awak pakai macam KC, KP. Same thing. Datang dari mana? Datang daripada equation awak. Product over reactant. Tapi reactant sebab dalam pure liquid. Okay. Sebab awak nampak liquid dekat sini. So terus ignore sahaja. So jadi awak punya KW expression nampak macam ni. It's come from your balance equation. Product over reactant. Okay. So carilah dekat sini value untuk OH minus. The concentration for OH minus. So using the KW constant. So we have 1.0 times 10 to the power negative 14 divide by the concentrations given in the value that Madam gave. So H plus H3O plus is the same. So divide by 1.5 times 10 to the power negative 5. What's the values? This is how you calculated the concentrations, from KW value. So how was it? What's the value you got? Is anyone getting the value?
6.62 times
6.62.
10 to the power of negative 10.
Okay. Very good. Well done. So this is how you calculate the concentrations if you want to know the concentrations. Either you want to find H plus or OH minus from KW. Okay. So now we have a formula, new formula over here. which is indicated by pKw. Okay, pKw equals to negative log Kw. So Kw is a constant value, so we just try to fill in the values over here. And then what do you get? Try to key in the calculator and then give me the value. pKw negative log 1 times 10 to the power negative 14, which will give you the values
14.
14. Very good. That's why your pH range maximum is 14. So pH plus pOH equals to a maximum 14. Here is where you calculate your you can calculate the pH value for an acid or for a base. Okay, so remember, if I'm giving you an acid, you can straight away calculate pH. If I give you a base, you need to calculate pOH. Then from here, you can calculate the pH value. I'll show you in a while. So after this one, I still got a few pages to go through before our calculation. Kalau sempat lah, macam tak sempat je. So until this part, is everyone alright? The pK value, the Kw value.
Boleh, madam.
Boleh ya?
Okay.
Boleh, madam.
Right. So a quick test. Bukan quick test lah. Just to ask a few simple questions. If both ion is present in a solution, I have the same concentrations for H3O plus and OH minus. What is the pH value?
7.
7. And it is, kenapa tulis kosong pula? It is considered as a neutral solution.
Solution.
How about if you have H3O plus concentration is more than OH minus? pH value, is it more or less than 7?
Less.
Less. And then we say it is an
acidic solution.
acidic solution because concentration of H3O plus is bigger. How about the last one? pH range? You got more concentrations for OH minus. It means your pH value should be
More than 7.
greater than 7. And then it is a basic solution. Okay. So we continue with the next slide. Next theory is your pH and pOH value. Okay, similar like our pKw just now. Just now we have pKw equals to negative log Kw. Okay, so if you want to calculate this pH value, we also got one formula, which is this one. If you want to calculate pH value, first of all, you need to know concentrations of H plus. Then apply the formula negative log concentrations H plus. Then you can calculate the value of pH. So remember that acid, you have a pH value lower than 7. For basic, it should have pH value more than 7. So we say that the higher the concentration of your H3O plus, or maybe H plus is the same thing, okay, the lower the pH value. Therefore, it is more acidic. But then if you're having a basic solution, you have a solution that is basic, we need to calculate the concentrations of OH minus and then applying the formula POH equals to negative log concentrations OH minus. So senang kata, acid pH, basic POH. Cuma basic kalau awak dapat POH, mesti kena kira balik pH. So first cari POH, second cari pH. Sebab kita hanya ada pH range sahaja. You don't have such thing as the pOH range. We only focus at pH. But the only way to get the pH of a basic solution is to calculate pOH first. So we can say that if you have a basic solution, the higher the concentrations of this OH minus, okay, the lower is the pOH value. Higher concentration, lower pOH value. So how about the pH value? Is it higher or lower for a basic solution?
Higher.
Nah, kita balik kepada benda yang kita dah familiar 0 sampai 14. Okay, so this is 7. And then I have two solutions, A and B. Okay, for this one, I have pH value equals to 8.5. For solution B, I have pH value equals to 13.0. Which one is more basic?
B.
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 Why B?
Higher value of
Higher
pH.
value of pH indicate the solution is more basic. So you need to link it. Lower the pH, yes, correct. But what is the pH? So jot down in your notes as well. The higher the pH value. Therefore, we can say this solution is more basic. Okay, again, pH equals to negative log concentration H plus. So straight away, pH. If you have a basic solution, find POH first, then convert into pH. Macam mana nak convert? Macam tadilah, pKW equals to pH plus POH. So say, if you have, this one definitely pKW is 40. So kalau saya nak cari pH value saya, let's say POH saya dapat 3.0. So awak carilah pH saya sama dengan 11. Tolak aja. Do you get me?
Yes.
Yes.
Okay. Right, good job. Yeah, okay. We try one more, this one before our simple calculations. Okay, the last theory over here for this hour, we have degree of dissociation using the symbol alpha. Okay, so alpha refer to the change in concentrations of reactant. Still the same, you can use symbol. Change in concentration, we use a delta, refer the differences of your reactant. Yang reactant column Madam letak RXT reactant tu ikut formula yang diberi dalam soalan. Contoh kalau ada N2, letak N2 kat situ. Kalau ada H2O, letak H2O tak ada. Kalau letak what else? HCl, letak HCl. Okay, and then over the initial concentrations of the reactant. So if you want to find the percentage, very easy. Just times it with 100%. Okay, so this is degree of dissociation. We will look through the example questions as well. But first of all, let's just try to calculate the pH value. So tadi Madam sudah tunjukkan dia punya formula. So Madam nak cuba untuk calculation pula. Okay, so calculation for strong acid, strong base. If you got the questions of strong acid, strong base, calculation very straightforward. So strong acid dissociate completely. Higher the concentration, lower the pH, more acidic, the short note for you. So question number 1, determine the pH of 0.15 mole of HCl solution. You can use istable, ICE, but in this case, we know that strong acid will dissociate completely. So if initially, you have 0.15 HCl. Okay, after dissociate, all the HCl will remains 0. Will become 0 because totally or completely dissociate. Okay, focus on the arrow, single direction only. So the concentrations of H plus now become 0.15. The concentrations of Cl minus also 0.15. If you want to put the CREC ICE table change in concentration, so sama juga tolak X tambah X tambah X. Tapi sebab dia completely dissociate, 0.15 semua akan jadi X. That's why you got the concentration H plus 0.15, Cl minus also 0.15. Okay. Oh, another method, kalau awak tak nak guna ice table, another method, if you have a strong acid or base, you can write it this way. concentration HCl equals to concentration H plus equals to 0.15 mole. Easier, simple, that's it. Okay, so now you got the concentration. We just substitute into the pH formula. Negative log concentration H plus or H3O plus. So substitute the value 0.15 and let me know what's your pH value.
Zero 0.8239.
Okay, pH value normally we take 2 decimal places only.
Okay.
Okay, so 0.82, very well done. So that means HCl very acidic because it's near to 0 already. The lower the pH, the more acidic is your solution. All right, try also question number 2. Again, practicing your, what's this called, the equation. Madam want you to practice the phases as well. So yang tadi punya pun kita letak HCl, H plus. For ion, always in aqueous. For solution like acid, always in aqueous, unless H2O is liquid. Okay, so Cl minus AQ. So for question number 2, you have KOH, strong base, no need water. So dissociate completely to produce K positive aqueous and OH negative aqueous. So the notes in the columns over here, madam gives you higher the concentration OH negative, lower pOH value. Higher pH value, more basic. Okay, so you can fill in the table or you can use the short notes over there lah. So initially K positive, no, nothing. Okay, so we put 0 over there. So after the KOH dissociate completely, 0.20 K positive, 0.20 OH minus. Or you can also write this way. For a concentration KOH equals to OH negative. Concentration K positive tak penting. Sama dengan 0.2 molar. But what madam write over here, madam yang highlight dalam warna kuning dekat sini, hanya untuk strong species only. Catat only for strong acid or base. So weak acid, weak base, dia ada cara pengiraan dia lain. Tak sama macam ni. Yang ini kira senang lah. So you are lucky if you get the questions related to strong acid or strong base. Okay, so substitute a value of negative so OH minus and calculate the pH value.
.7.
Okay.
0.7.
0.70. Is this our final answer?
No, pH.
pH kan? Okay, kita balik kepada soalan. Determine the pH value. Sekarang awak cari pOH. So, bukan final answer lagi. So, in order to find pH value, use 14 minus the pOH value that you have calculated just now, which is 0.70. And you get 13.30. So makes sense lah. A basic solution will have a higher pH value, especially when you have a strong base. The stronger the base, the higher the pH value. Is everyone alright?
Yes, madam.
Alright.
Boleh ikut ya?
Boleh.
Alright. So this one, question number 3. Madam tak bagi tempat kosong saja awak buat kegiraan sendiri. Kita buat question number 3, last one. You're giving a volume, you're giving number of mole. We can calculate that. Is this an HNO3 strong acid or weak acid? NO3.
Strong.
Strong. Okay, one of your 7 wonders, this is a strong acid. So to calculate your concentration of the nitric acid using number of mole divide by volume, but remember to convert it into liter. Okay, you'll calculate first. Let me know what is your pH value. We check it together. You try dulu Madam nak dapat jawapan. Before that, I share the link with you first. Anyone got the answer ready?
One point three.
1.3. Everyone's agree.
1.20. Tak tahu.
1.20. Okay.
Yes, agree.
Agree. Concentration dapat berapa?
0.05 molar.
0.05 molar, which is also the same as H plus. So we can write down the equation to practice. Strong acid dissociate completely to get a H plus and NO3 negative. So boleh nampaklah ratio dia sama. So kita boleh terus ambil H plus sama dengan concentration HNO3, which is the same as 0.05 molar. So to calculate your pH value, negative log concentration H plus, applying your value 0.05 to get 1.30. So this is only for the strong acid, strong base. So question number 4, you can try it as well. Question number 4 can try it as well. So in this case, it gives you pH value. Calculate the molarity. Calculate the molarity of FeOH2. Okay, so madam give you the guideline. So first of all, equation. Okay, second, calculate concentrations of your OH minus. Before OH minus, maybe you can calculate for POH first in order to calculate concentration OH minus. And then last one, calculate the concentrations of FeOH2. So step madam bagi, jawapan madam nak tengok untuk next hour untuk kelas masing-masing lah ya. Please remind madam kita stop sampai mana sebab madam ada 4 kelas, takut madam tercampur habisnya progress. Okay, so can you open the link in for Google Form?
Boleh.
Yes.
Still loading. Oh, already done.
Okay. So that's all for today. MS8 later, madam maybe will take 1 hour only. You got 2-hour class, right? The first hour, madam will explain what to do. And then the second hours, you're going to complete your work. Okay, so we'll Google Meet 1 hour. Then the second hour, you do your work.
So during the duration that you give us work, we have to submit our work during that time period too, right? Or
No, it's the same. Lab report, madam still give you today. 2 hari, masa sama 2 hari lah. Okay. So MS8, I'll see you again at 2 o'clock later. So 2 to 3, Google Meet. 3 to 4, you can do your work. Okay.
Okay, madam.
All right. So that's it only for this hour. Thank you, class.
Thank you,
Thank you,
madam.
madam.
Thank you,
Hey,
madam.
madam.
Thank you, madam.
Thank
Thank
you,
you.
madam.